Hello everyone and welcome to the 1000 subscriber milestone video. That's right, thank you all so much for subscribing to the channel and helping push us over that big 1000 mark. I mean, we can look here and just wait, am I reading this number? Nope, wait, that's a lot of subscribers. Well, hello and welcome to everyone new to the channel. It seems like over the past few days, some of my videos, especially the stair video, has got hundreds of thousands of views. Literally more views than my channel has got for the whole time I've been making videos. Thank you so much for all the interest and support on these videos. These game development topics can be quite niche and specialized, but I'm really happy that other people are interested in seeing the kind of work that I do on them for fun. Well, I guess I missed those 2,000, 3,000, and 4,000 milestones already, but I guess now's as good a time as ever. Let's show off and welcome everyone else new to the channel by showing you all what I've been working on. So for the past few months, my friend and I have been working on this game based on a board game that we really like playing, but we thought a little fun sub-scenario of this for the 1,000 subscriber mark would be a cool celebration to turn all my subscribers into zombies and fight them in the game. I know it sounds a little bit weird, but it just seems like a really cool way to, acknowledge everyone that's helped to get me to where I am now. Also, it seems like from the comments in the previous videos that a lot of people are interested in these more in-depth videos, so I'll try to go a bit more in-depth in this topic and make a longer video for this milestone. Alright, so let's go over what the general plan is for this milestone video and project. So, originally, before the channel got those extra 3,000 subscribers in the past few days, as of this recording, thought that, over the next month or two I could plan out this fun 1,000 subscriber celebration video. So the game that we've been working on is kind of a video game, real-time version of this board game called Betrayal at House on the Hill. A bunch of different people go into a house, you explore it, somebody goes crazy and wants to kill everyone. The B-horror movie, but in board game form. So to show off currently what we have, which is basically just a combat system, we thought it would be fun to just fight all the subscribers. Back when it was 1,000 subscribers, that was a very reasonable goal. Well, still not the most reasonable, but now that it's 4,000, it's going to be pretty hard to fight that many people, so I'll definitely need some help. That's why I'll also get to show off the multiplayer. That's right, I'm going to drag in my friends, and a bunch of us are going to all fight all the subscribers together. And it would be a little bit weird just to kind of fight all the subscribers, so we need some justification, and we're going to turn all you guys into zombies first. Hello there, zombie subscribers. So, dragging a couple of my friends into a Discord call, we all hopped into the game and demo that we had set up, and this is what it kind of looked like.
Choose your character. Ready to take down some subscribers? Die! Oh god, they got me! I was killed by Pew Pew! Jordan! Jordan, save yourself! Looks like Trisket H has murdered you. Here, I'll take care of the subscribers getting me, then I'll get to you. Oh, I ran out of stamina. Gotta run. Ooh. Ooh. Oh, I'm still stuck in the maze! Don't abandon me, Jordan! Don't abandon me! Well, it looks like you got a horde of zombies on you, so good luck with that. Wait, did you lead them into the maze? I think they got you. I'll avenge you! Oh, they got me too. Oh, that would be funny if we had like an area that was like a pit of death and you could like dodge around them. Hey, teamwork makes the dream work. Friendly fire, never heard of him.
So, not gonna lie, that's a pretty fun game. I mean, at least I think so. I'm recording this before I've recorded the time with my friends. Now, I know I haven't talked about this project very much right now, but I think it would be fun to just go over, how I made this game, how I crunched it into the past 3 days to try and get it done as close to that 1,000 subscriber mark, despite missing it by a couple thousand. I mean, each of these topics that I'm going to go over could probably be their own 10 to 15 minute video, but I'll just try to give a brief overview of how they work, so I can just show you guys some of the cool stuff that went into making this game. To make it a little bit simpler and easier to manage from now on, there's going to be 3 big categories of stuff that went into making this. 1, the game mechanics, which is things like, the whole player running around, multiplayer, combat, and weapons, putting all those things together. The second big topic is those zombie enemies. So once we can run around and fight stuff, what do we fight? how do they act, and how do we make those interactions work over multiplayer, since, you're going to need some help to fight that many zombies. And finally, how did I go about getting all the information about my subscribers and then turning that into zombies in the Unity game? I think these are some pretty cool interactions, and let's dive into how they all work. Each of those are some pretty big categories, but let's just go through them in the order that I made them so that you can kind of see how the whole development process went through. One of the really big things that we wanted to maintain from that board game when we were designing this interactive experience is that we wanted it to be multiplayer and something you could do with your friends. We really wanted to make sure that that was kind of a core feature and something that we focused on as part of the game. I made another video in the past going over how different multiplayer games can work and how their interactions can be handled over the internet or in local players. Just as a really high-level overview, this game was configured as a host-client model where one of the players hosts the game on their machine. I already have an example of this kind of network character movement and interactions in my previous OpenKCC project, so I could just pretty much copy and paste that to get it to work in a really basic manner. Each player, when they join, we create an avatar that they're allowed to move around. And another requirement for this is that a bunch of my friends don't want to download some random executable I send them, so to get around that problem, I've actually created the game as a WebGL build so that they can just go to an IP address in their web bar, similar to my OpenKCC demo, and they can join the game session that I'm hosting via the website without having to download any program that I send to them, since, it's all embedded in the browser. The browser does have a little bit of a performance downgrade compared to the game, but it's still able to use your GPU to render things. It's just a little bit more limited in how much it can be optimized. Unity's done some really good work with their WebGL builds, though. It took a bit of finagling to get working with multiplayer and the new Unity networking for game objects, but I think its solutions turned out pretty well so far. So now that we have some basic avatars and the ability to walk around copied from my other project, something that I wanted to add to this, the first thing is just, kind of health and death and making sure that your character can be damaged and deal damage to other things. This might seem like really straightforward, just save a number of each character like how you track health of characters in a D&D game. But it's a little bit more complicated than that because this is multiplayer. So each player in the game has a health bar and a stamina bar. The stamina bar lets you perform actions while the health bar measures, how much health you have and whether you're dead or not. I decided to set it up so that the players control their own health and stamina on their machine. That way they can have quick and fast responsive actions, and as soon as the player dies, it stops their actions, and as long as you're alive on your screen, you can still perform actions. This can sometimes lead to a bit of a race condition where, let's say on your screen, your character attacks my character and you would kill me, but on my screen I attack your character, so we both end up defeating each other at the same time. I'm not too worried about these kinds of interactions because this isn't meant to be a highly competitive game, but it is something to take into account when deciding how to design your game in the future. As an example of that messaging system that I had mentioned earlier, let's say that player A wants to do an attack and deal damage to object B on the screen. The first player would need to send that message to the server saying, hey, I want to attack this other player. Then the server would have to look at that action and say, okay, that's fine, and lets player B know that they were damaged for a certain amount by player A. This means that for that message to happen and for the effect to take place, it would actually take quite a few different pings between the different clients to fully process that. This is prone to cheating and lag spikes, but this can be compensated for with a server authoritative model and allowing rollback if needed. But since this is a cooperative game where everyone's working together to defeat an enemy, I figure it's not that big of a problem to give the player an advantage when fighting the enemies for now. Basically, whenever a player wants to do an action or an attack, they just tell the server, hey, I'm doing action X, and the server processes that and relays the information back to all the clients. Another important interaction to add here is that when a player gets attacked and their health drops to 0, they have to die. Now, that's going to involve adding not only processing and stopping their input when they die, but also death animations. Right now in the OpenKCC project, the character couldn't take damage, so there's no reason to add a death animation. A couple of the different assets and models that I've added to my game are actually from this nice website called Mixamo, hosted by Adobe. They have some great resources for animations and humanoid avatars. That's where the Michelle character for the OpenKCC demo comes from, as well as a lot of the animations I've attached to her. I know these animations can be improved with procedural animation and inverse kinematics, but that's going to be a future topic. For right now, I just wanted to focus on getting this small demo out. So I could go to the Mixamo website and download all these different animations. import them into Unity. Now, I don't actually like using the default animator to manage my characters, as I find that web of transitions and graphs really confusing to manage. I'm going to get a little bit more into this later when I talk about the zombies, but I basically just had to add a new state to the player that says when the player's health drops to 0, put them into a dead state, and play the death animation. So now that we have some death, we probably want to make it a little bit more interesting by adding weapons and attacks. And thinking of weapons and attacks and actions in a game, this also kind of brings up the concept of an inventory system. Imagine that if a player is holding a weapon or something, they'd attack using that weapon instead of punching, but if they aren't holding anything, they'd punch. As a kind of close analog, think of like in Minecraft where you can punch objects, but if you're holding a pickaxe, you start mining those objects, or if you're holding a sword, you start attacking. Now, I could have gone with a really simple proof of concept system where I just had a character have one item that they can hold or drop, and that controls what action they do. It would be a really simple system, easy to manage, and perfectly fine for this video. Did I go with that? I wish I would have, but I didn't. I made quite a more complicated system where a player could have a main hand item and an offhand item, which actually is in Minecraft as well now, but let's not worry about that. So when you have a main hand item and an offhand item, the reason we split it up this way was that you could do something like hold a sword and a shield, or maybe hold like a flashlight and a small weapon, or maybe an object, or maybe you have a flashlight in your offhand but can still punch if you're main hand. There's lots of different complicated ways that this could be put together. But we decided to simplify it by having a loadout consist of a main hand and an offhand item. The reason we wanted to allow for holding both in a set is that you can make like a set of a sword and a spear, and maybe your other set is a bow and arrow plus a quiver. Lots of different combinations there. And you'd be able to use each of the items in your main hand and offhand independently and swap between loadouts depending on what your character wants to do. And I know this sounds pretty complex and all, and it kind of was, but it's fairly straightforward once we had the design fully laid out with Jordan. Oh yeah, I don't know if I said who Jordan is. Jordan's my friend, also a fan of that board game Betrayal House on the Hill and video games, and he's helping me work to the project together. This kind of system of a main hand and offhand item is actually very similar to a system from a roguelike game that we like playing called The Last Spell, where every character can have two loadouts of a main hand and offhand weapon set. That way, like if your character wants to be something like a fighter, you could have maybe a spear as one of your loadouts and a sword and shield as the other loadout, while if you wanted to be an archer, you could have a bow and arrow and a crossbow, or if you wanted to be mixed, one of your loadouts could be ranged and one of your loadouts could be melee, depending on what your character wants to do in the game. So back to the items. Any player can have one loadout active in the time and one loadout just in their bag. In order to manage what the active loadout and the other loadout is that we have the game spawn copies of items and attach them to the player hands whenever you activate a loadout. Whenever you deactivate that loadout, it just, deletes those items so they aren't visually there anymore. There also might be some different animation constraints depending on what the player is doing, but we have a lot more to do there now. So we have some items. When you activate a loadout, they appear in your hands. You can drop them onto the ground if you want or pick them back up. But it's also completely broken over multiplayer, because just because I pick something up on my screen doesn't know that the another player would know about that. So we have to ensure that we synchronize this kind of current visible loadout between each client and the server. So that way the server can send that information to all the other clients. And let's say you're holding a sword or something, the server can tell all the clients, hey, player A is holding a sword. You should load a sword on your screen so it looks like he's holding it. That way we can communicate what's happening. This is a fairly straightforward problem to solve, but still required quite a bit of bug fixing to make sure that the loadouts are synchronized properly. And let's say I pick up a sword, but someone else joins mid-game. Do they still know that I have the sword? So I have to save it as a persisted state and make sure that we synchronize that to all the clients, making sure all these messages happen in the right order. It can get kind of convoluted to manage all these commands, but after way too much bug fixing, we eventually worked it out. So now we have an inventory and items that we can pick up. Let's turn those items into weapons and add it into some combat. Now, before we can add these more kind of complicated weapons, let's first focus on a simple attack, punching. Punching in the game would just be a basic attack that you can do when you aren't holding any item. In order to check this, whenever the player does the attack button but isn't holding a weapon, we just check and do a little punch animation. While you're doing the punch animation, we just check if something's standing in front of you. If there is something that you can damage in front of you when you punch, we let you attack it. To kind of test this out, in the game scene, I added some breakable objects so that when they're damaged, they break into a lot of little pieces. I achieved this in Blender by just doing a little fractal modifier on it to break it up into a lot of different sections and make them all rigid bodies in Unity. In addition to that, I also made what would simulate attacking another player as like a little target dummy that would shake every time it gets hit, and whenever its health drops to 0, it would die. This is how I tested out a bunch of those death animations while having one client, so I didn't have to keep on, booting up multiple instances of Unity to test everything together. So, now that we know what we want to do when we attack things, how do we actually check whether we've attacked something? Well, Unity has this nice operation in its physics library called a raycast, where you draw a line from the player forward. That way we can check if we hit anything. But what are we trying to hit exactly? So one of the problems is that doing a complicated calculation based on like what the shape of a character is would be very expensive. Instead, what a lot of games usually do is they take the armature that controls the character and attach some hitboxes to it. These hitboxes will generally line up with the shape of the character, but usually they're limited to simple shapes like spheres, boxes, and capsules, while the character, is obviously a humanoid shape with lots of different things moving around. So you usually just try to get a close approximation of like where the head, torso, arms, and legs are. So we can take all of these hitboxes and put them on a physics layer in Unity, and then whenever a player tries to attack, we just need to check if we hit anything on that physics layer. We also have to check to make sure we're not trying to like punch through a wall or something. So we want to ignore objects that are like the player collision mesh, but include objects like walls and floors. And that way when you try to punch something, you can see, hey, did I hit a hitbox? If yes, trigger a hit at damage event. If not, we only have to just finish up the hit animation and not trigger any attacks. So when Jordan and I were doing some design, we agreed that out of the weapons, we'd want 3 main types of melee attacks: slashing, cleaving, and piercing. Think of slashing like swinging at a sword. You'd hit one target in front of you, and it would be a fairly short range. Cleaving would be a little bit shorter range than slashing, and you would hit all the targets around you in a short radius. Think of like spinning a sword around yourself in some kind of anime or RPG game. And the last kind of attack, piercing, would be like, imagine you have a spear or something and you can drive it through multiple enemies ahead of you. Each of these weapons has a little bit different set of requirements and constraints, but they actually are more similar than they might seem at first. So every one of our weapons, the sword, spear, and axe, are all actually managed by the same script. What we do is, instead of like from the punch where we'd only draw one line out, we draw multiple lines out based on the size of the attack. The sword, which is a slashing attack, just does a small radius out, maybe 10 to 20 degrees, and checks if you hit anything inside of there, and creates a damage event. The axe, on the other hand, which spins around the character, does, I think, a 270 degree check around the character to see if we hit anything. And if we do, it creates a damage event for every unique object that we hit. Although if there are multiple hitboxes attached to the same character, we don't hit every hitbox. We just hit the closest hitbox of that character. And the slashing attack would have an even tighter radius than that of the sword. I think we set it to around 5 to 10 degrees. And when you do that attack, instead of just hitting the first target like you would with the sword, you go through and hit all the targets in a piercing attack. So that's how each of the hits are computed for the different kinds of attacks. And then in addition to that, they all just have, a different damage event, how much damage do they deal, what's the cooldown between attacks, and also selecting different nice animations that we found from Mixamo. That just kind of adds some nice communication and flavor and makes it look a lot better than it would initially. So now we have the design and code for these weapons, but I'm not what you might consider a very talented artist, so I asked one of those nice AI image generators to give me some concept art for the different kind of weapons. And after a little bit of adjusting the prompts, putting it in a nice setting, it gave me some pretty cool designs that I think I could actually work with. So these are just, 2D sprites and not a whole model, but I do know how to use Blender, and with a reference model, some nice textures, and a little bit of YouTube tutorials, I was able to make each of these weapons in Blender, give them some nice texturing, tiling, and maps, just to give them all like life and have that shine on them. I'm not making these very high poly, but with some normal maps and lighting adjustments, they can actually look quite nice, even with procedural materials. Taking these nice models made in Blender, we can export them to an FBX format and import them into Unity. assign these different models to the different weapons and objects that will hold them when we attack, and they look like that when we put them down. We have to do a little bit of work to convert the materials from a Blender material to a Unity material, as they aren't always compatible. But overall, I think the general effect looks very nice and is at least passable for this basic first demo. I'd love to talk more about the different game mechanics, like the kind of stamina and combat system, but I think I'll leave that for a future video. All you gotta know for now is that in addition to a health bar, every player has a stamina bar, and whenever you perform an action, you're spending some bit of stamina. Some actions spend stamina instantly, like an attack, while other ones, like sprinting, spend it over time. And it's a really nice foundation to the system, really kind of similar and inspired to games like Breath of the Wild, where you might have to choose whether you attack or run, as they both cost stamina, and staying in a fight might mean you can't run away later, or running away now might mean that you don't have enough stamina to fight directly after. That's the general basic overview of how the game works via the multiplayer system to send messages and communicating data, configuring the damageable and allowing players to die, different loadouts for weapons and items, as well as unique weapon attacks and different configurations to give us something interesting to fight the enemies. Now that the players can die and fight things, let's give something to fight and something that'll fight back instead of just the training dummies I added earlier. What better to kill than a horde of zombies? You can just pop over to that Mixamo site from earlier, download a few rigged zombie avatars. A rigged avatar just means that it can be animated in a video game and have a set of internal bones for deforming the mesh. We can import all these assets into Unity. Controlling animation in Unity, as I talked about earlier, is usually done with an animation state machine, but these kind of end up turning into these webs and massive headaches for me, at least, to manage, and I don't really like using those. However, I do like the state machine design. I just wish I could modify it via code instead of through that kind of graphical editor. So to get around this, I made my own state machine library to control the animation controller and manage the internal state of an object. I called this a state machine Unity library, and I'll probably make a follow-up video on it going over how it works in the future. But just for now, you just need to know that the state machine has an internal state, define transitions between states, just like Animator. However, my state machine is configured via attributes in C#, so it's really easy to manage and version control instead of that, big web of different events. So to get this to handle in a believable way, I added a few different states to the zombies. The first state we'll talk about is the idle state. This is just when they stand still and don't really do anything. Next is the roaming state. Ideally, the zombie would just roam around randomly on the map and kind of towards the player, a passive threat, but nothing too scary. Then, once the zombie's found something and wants to chase it down, there's the chase state. This is when the zombie would start running and chase down the player. And finally is the attack state. The zombie would change into this whenever they're chasing them and close enough to attack. And if for some reason the zombie's health drops to 0 and the zombie's dead, we have a final death state that the zombie can never leave. Now, that might sound like a lot of states, but with my state machine library, I can set each one up as their own class, define a different function and behavior for what they do when they're in each state, and define transitions and events for managing all of them. Inside of these functions and behaviors, I can actually emit the events that would cause these transitions. For example, whenever the zombie's idle or roaming, they actually are looking around within 5 meters of them. If there's a player close enough, they're going to start chasing them, and then they'll also raise an event to all the zombies around them within some given radius that there's a player nearby to start chasing. And one of the interesting parts of the state machine is that if other zombies aren't in that desired state or, aren't ready to listen to that kind of event, they'll just ignore them. So something like a dead zombie does not have a transition from the death state to the chase state, so this won't suddenly revive other zombies nearby to start chasing the player. Now, I know I mentioned chasing the player earlier, but that's kind of involves some complex pathfinding, right? I mean, don't get me wrong, I like to code, but coding my own 3D pathfinding algorithm, that's a little complex, and Unity kind of already has something for this. Inside of Unity, there's this concept of a navigation mesh and nav mesh agents. This creates a space on the map that can be navigated under some certain set of parameters. It allows us to create a navigable space in the world and mark different obstacles, so the zombies can navigate around and find the closest path to a certain point or player, and run towards them. To get this working, we just had to add a nav mesh component to our zombie, and inside of our state machine, we can get this nav mesh component and configure different factors of it, like the speed, how fast they can turn, and what its current target is. So when they're in the roaming state, they'll just be navigating towards some arbitrary point, or generally toward the player, but slowly. But when they're in the chasing state, their speed would increase significantly, and they would be tracking right towards the player instead of just milling about randomly. One of the other really nice features about the nav mesh is that it can account for jumping over obstacles and jumping down ledges. So this is a really cool feature to have, to be able to jump between gaps. In the nav mesh, it's something that's called an off-mesh link. However, one of the problems with the default implementation of a nav mesh agent is that they don't actually account for the time it takes to travel over these gaps. As soon as a character walks up to the gap, it just teleports across it. Which, don't get me wrong, it's still pretty scary if zombies, but it doesn't seem very fair if you feel like, you got 5 feet between you and them and a big gap, and all of a sudden a zombie teleports across it. Thankfully, some other people had this problem in the past, and I was able to find an existing solution on Stack Overflow. What they ended up doing is using the animation controller, and since I was using my state machine instead, I just added a new jumping state so that whenever the zombie enters a nav mesh link that joins 2 separate parts of the nav mesh, we just need to transition our zombie into the jumping state and play the jumping animation and smoothly translate them across. I had done something like this similarly for various different player animations, like some of the dodge and roll actions, so it was fairly easy to add in. And once all that was added in, it was way more effective than I was thinking, because the zombies are absolutely terrifying when they start jumping off cliffs between you and jumping over gaps and just crawling towards you in this really creepy animation. Way scarier than I thought it was, and I hate it, but it's great for the game. And the last thing to do was just to manage when zombies can spawn in the game and where. For right now, I just wanted to keep it simple and just set up a couple of different spawn points across the map. Each spawn point is just a position and a small radius around it. That way, we can spawn zombies in different areas, but not have them all stacked up on the same exact point. And in addition to those spawn points, I have a spawn manager, which has a specific target number of zombies. Because if we were to spawn all 1,000 zombies at once for every subscriber, it would probably just crash my machine because my code isn't that optimized. Whenever a zombie dies, it'll just wait a few seconds in the dead state, and then the zombie manager can dispose of the body and spawn a new zombie to reach that target count. This is actually some fairly complicated code to manage all this efficiently without having to loop over every zombie every update frame. So whenever a zombie is created, we actually set up a callback function to let the zombie notify the manager whenever the zombie dies. And when that zombie dies, we add that zombie to the start of a linked list of all the dead zombies that we're tracking. Every update cycle, we can just simply check the zombie that's at the end of that list, the one that was killed the longest time ago, and check if it's exceeded its cleanup time. If that zombie has exceeded its cleanup time, we just have to clean it up and spawn in a new zombie. This allows us to manage cleaning up all the zombies in one loop with only one check. Because if the zombie that died the longest time ago isn't ready to be cleaned up, then none of the other zombies would be ready to be cleaned up either. That way, instead of having to check every zombie every update frame, we only need to check the oldest one. This wouldn't really make a big problem for like 10 or 20 zombies, but ideally we'd be spawning a lot of them, and having every single zombie check and count a death tracker would actually be quite difficult to manage, and could lead to a lot of wasted compute resources. So it's just good to add in these kinds of optimizations whenever possible. Now that we have the ability to create zombies, let's work on turning all the subscribers into zombies for this 1,000 subscriber or 4,000 subscriber celebration. I know that this video has been quite a few long tangents, but that's actually kind of what the development of this project was like for a lot of hobby games. And I think it's really good to focus on what you want to dive into and learn more about, but also know when it's a good time to step back, focus on finishing up and avoiding that scope creep, and refocus on the project. Seeing how I passed that 1,000 subscriber milestone very quickly, at about a week ago or so, I decided it was time to adding the finishing touches to the project and get this video out and ready. So the first thing that I wanted to do in order to turn my subscribers into zombies was to give all the zombies names. That way we can make the zombies seem like the subscribers. I mean, we can't have zombie subscribers without naming them after all the people that follow this channel. So to do that, I just create a 3D text object over the head of a zombie and point it towards the camera. We just need to set this text to the name of the subscriber. Also, I wanted to make this feel a little more fun, so there's a strength factor associated with each zombie that controls their size, damage, attack speed, and a bunch of different factors. And I figured it would be fun to make it so that people who have been subscribed to the channel for longer and left more comments on the channel spawn as a bigger and stronger zombie. In addition, since you may not see the name above each zombie's head, I also added a little kill feed to the top right of the screen. Whenever a player kills a zombie or a zombie kills a player, a little event will pop up in the kill feed. This is managed by just creating a small little game object that I called a death feed entry. This just has a name a little symbol to show that it was killed, and a target. This will happen every time that a player is killed. Now, the way I tracked this in the code was actually by creating a C# event handler for all the damageable objects called AnyDeath. Whenever a character dies or is killed, a new AnyDeath event is created from that source object that was killed, identifying what damage event killed it. The death feed in the top right of the screen simply needs to subscribe to this AnyDeath handler and just create a new death feed event every time someone dies. Then, as long as there's an element on the top, it'll just scroll down to show, what's the most recent death events and more events that are pending. The faster it'll scroll. That way, it'll kind of give you that scrolling kill feed effect that a lot of shooter games have. So, now we can name the enemies, get attached to them, and see their name pop up when they're killed. Let's work on getting them listed from the subscribers. So, as a programmer, I always strive for, why do something manually for 15 minutes when I can instead spend 5 hours failing to automate it? As you may or may not know, YouTube actually has an API that lets you query all the different events and statuses of channels and videos. After brushing off the dust from my Python skills, I bravely opened up my code editor, the documentation, and started reading. And after briefly opening the documentation, all that text looked scary, and I thought maybe I should reconsider this. But I really wanted to do this, and hey, it's 2023. ChatGPT, Stable Diffusion, all these different AI tools, they're kind of popping off right now, so maybe we can let them do the work for us. So I asked ChatGPT, hey, can you write me a script to give me the list of subscribers to my YouTube channel? This was my first time using ChatGPT in one of my projects, so I wasn't quite sure what to expect. And after giving it a question, I was quite surprised to see that it gave me back a reasonable looking script with some comments and notes saying what it does. I thought this looked good. ChatGPT said it would work as long as I gave it an API token, so I put it into the Python console, plugged in a token, gave it a run, and it gave me a list of subscriptions. My subscriptions. Wait, that's not what I asked for. I wanted subscribers to my channel, not my subscriptions. I went back to ChatGPT and politely said, hey, this script isn't exactly what I asked for. I wanted to know who's subscribed to my channel, not who I am subscribed to. And ChatGPT politely apologized and gave me back a new script of some updates in order to fix the errors it made. Very confidently, I took these new updates that ChatGPT created, plugged it into Python, and it gave me my channel name. Over and over and over again. Yeah, that's not right. Maybe this AI code thing still needs a bit more work. So at this point, I actually brushed off my Python skills and went into the YouTube ATI to see what was happening. Turns out, ChatGPT was actually kind of close, but didn't really understand the assignment it was given. When you set up a query, it actually grabs a subset of your subscribers, and you need to iterate through all the pages of them, similar to what you do in your YouTube Studio page. This gives the data on who you're subscribed to. Also, it turns out that Google's API documentation has an interactive UI for testing, and that UI can generate some code for debugging and writing tests. And it actually gave me working Python code, unlike ChatGPT. So with this improvement, I continued to work on the script, but ran into an issue. It could only ever give me like 1,000 of my subscribers, which is nice for the 1,000 subscriber video, but we're well beyond that point. It's now at 4,000 subscribers. Why'd it keep on stopping at 1,000 subscribers? Well, it turns out if we read the fine print, YouTube will just actually say, if you have more than 1,000 subscribers, this command may not work as you expect. I just thought, well, maybe I'll have to query them up a couple of times, or there'll be a long timeout. Nope. YouTube just straight up refuses to give you the whole list. Documentation says it just probably won't work as expected. Well, that kind of sucks. I don't have the list of all the subscribers, but I can get 1,000 of them. 1,000 subscribers is better than nothing, but hey, this gives me an excuse to look at the comment section more. So I could use this API to query all the different comments, and check out all the people who have commented. I could manually check if that commenter is subscribed as long as they had their subscription list public. A bunch of you guys didn't, which is fine. It's fine. It just makes it a little hard to tell when you initially subscribe to the channel. But I just decided that, I'd create a name zombie for every subscriber or person who commented on the channel, which at the time of writing the script and recording it was around 1,800 subscribers and comments that I could query via the API. I wrote another Python script to take this list of subscribers and commenters and gave each person who has either subscribed, commented, or both a point score based on how long they've been subscribed and how many comments they've left on the channel. So, if you want to be in a video like this in the future, make sure to comment and subscribe. Oh yeah, getting in that call to action seamlessly. No transition required. So we just need to hook up this code. I exported that list of subscribers and scores to a JSON file, and then using some fancy C# code that I borrowed from Stack Overflow, I can parse that JSON and read it straight into Unity. Whenever a zombie spawner creates an enemy, it'll give it the name and the strength of a random zombie from that list. Great. Now we have the multiplayer combat, items, zombies, and the most important ingredient for this recipe, the subscribers, you. So this effect is nice and all, but where should this epic showdown take place? Well, while I was busy writing all of that awesome code earlier, my friend Jordan was actually working hard on setting up the test level for the zombies to navigate. After explaining the basics of version control, Git, Unity, and a bunch of other things over a series of Discord calls, we could merge our changes together and have the zombies in an awesome arena that Jordan designed. By the way, I think Jordan took this assignment a little bit too seriously. He added a maze where the hordes of zombies can spawn, sneak up on you, and jump scare you. Why did you add that, Jordan? It's terrifying enough when they can jump off walls, but now you also can't see where they're going, and you also asked for me to program that horde mentality where they'll act as a swarm? Well, at least it's good game design, and you definitely really like working on this. Way more scary than it would otherwise be, but that's the whole part of this. Now, here we're still kind of missing the game loop of a whole reset, scoring, time limit, but adding all those things together would be a big example of scope creep and push this back even farther than it's already been, and we've already blown way past that 1,000 subscriber mark, so let's just try to get this done before the subscribers grow even more. Seeing how I have to kill that many zombies, let's get a bunch of my friends together in a big old Discord call and try and fight all the zombies together. Let's go.
These zombies seem to have lost their way. There may or may not be a lot of bugs left in the game. Here, I'll grab some zombies to chase us in the maze. Don't worry. Hey there, zombies. Do you wanna see if you can find my friend JK and kill him on top of the maze? All right, let's go. They might not be able to jump this far. All right. I guess I should have seen that one coming. Zombies are just standing over my corpse, enjoying their handiwork. Let me just play my get up animation. Just kill the zombies while they're distracted. Hey, I killed you too! Alright, we gotta kill zombies until we get another spawned group on top of the maze. Chop, chop. Oh yeah, chopping down the subscribers. Alright, don't chase me into the maze, zombies. Don't do it. Oh god, there's so many of them. Oh, there's so many of them. Die, zombies. Did you just stab me? You just stabbed me. Oh, there's another pile of zombies in the maze. I'm trying to do your parkour course you put here. See, like, the zombies can't touch me now. But I can hit them. Wait, can I hit them? Oh, they're too far away. Oh, good luck, Jordan. Oh. Sword. Oh, there might be some bugs left in the game, seeing how my console's filling up with bugs. What? Hey! You leave me alone. I'm gonna block this. Ah, got him. Man, you made it a good distance away from me before that hit registered on your screen, didn't it? Doesn't seem like they're chasing you very much. Maybe they just forgot that you exist. What? My code's buggy. Who would have figured?
So yeah, I hope you enjoyed seeing that epic journey of me turning this hobby game project into the subscriber milestone video. Getting this demo out definitely took a lot more effort than I thought. Yeah, who knew programming and time estimation isn't the best for software engineers? Well, you can download a demo from GitHub as of the project right now. Hopefully it'll be uploaded by the time the video is live, and you can fight the group of subscribers on your own. There isn't a score system or timer yet, but hopefully I'll add those as a fun scenario in the future. I'm going to try and resume work on some of the other features, like different kinds of items. We'll definitely need to add something like firearms to make killing huge hordes of zombies actually possible. Keeping score, visual effects, all these are great enhancements to add, but just scope creep I wanted to leave out of this for now. Jordan and I are working on this as our Treachery Betrayal board game project, so I'll keep on adding more updates when I have more to share, or make videos about some of the features I touched on in this video. The zombie fighting might even be one of the haunts for the game in the future. So much fun things I have planned for that, but I just wanted to make sure that I get this video out now. Thank you so much for subscribing and supporting the channel and commenting on the videos. I've really enjoyed looking at what different people have to say about the projects and sharing this love of game development and current work that I'm doing. I'll hopefully try to get back into the OpenKCC project and make some more follow-up videos on the project's improvements when I get more time. It's been really interesting talking to people in the comments sections about different kinds of designs. I definitely have a bunch of new ideas about stairs and moving platforms based on my conversations with people, and I'll try and get back to that backlog of comments. I've kind of, gone a couple of days without responding to comments here in order to try to get this video finished. If you have any suggestions for the project, all these are open source, and you can check out how they work on the GitHub repo. Open up issues if you see anything that's wrong or have any suggestions. I'll try to link to the GitHub repos in these videos whenever possible. Thank you so much for staying to the end of the video. Your engagement and subscriptions to these videos has been really great, and I'll try to do more projects like this in the future where I feature the subscribers and comments. Have a great day, everyone.